I've been in networking for over a decade and decided to make some content to try to help others understand this industry. Let's talk about the different network communication types. The most common one is Unicast. This is the one people are the most familiar with. In Unicast, you have a single sender and a single receiver. That receiver is listening for traffic that has its own addresses assigned to it, and it's processing that information. So this would be used for like web browsing, direct messages, file transfers, that type of traffic that we use all the time. Now, if you have one sender and you want that traffic going to multiple receivers, we call that multicast. So in this situation, the receivers aren't actually listening for traffic that's destined to their configured addresses. They're listening for traffic that's assigned to specific destinations. So layer 2 for this has a specific multicast MAC address range, and it starts with 01005E. And then at layer 3, there's a specific IPv4 address range for multicast, and it's 224.0.0.0 through 239.255.255.255. So these addresses aren't actually assigned to the receivers. They're not configured on the receivers. The receivers are just listening for traffic destined to those addresses. Now, if the traffic is intended to be sent to everything that's on the network, anything that's reachable, we call that broadcast. So broadcast traffic, similar to multicast, it has some specific addresses that are used, but the endpoints themselves are not assigned to these addresses. They just know to listen for it. So at layer 3, the IP address that they listen for, it depends on the network that they're assigned to. So we're not going to go super deep into this at the moment, but there's a combination of the endpoint's IP address and subnet mask that tells the endpoint which bits are network bits versus host bits. And if all the host bits are set to 1, then that's the broadcast IP address. So that changes based on which network the device is connected to. The layer 2 broadcast address is a little simpler. It's just if all bits of the MAC address are 1, then that's the broadcast MAC address. So in that situation, if all bits are 1, the MAC address would just be all Fs. So broadcast traffic itself is limited to the device's layer 3 network. IPv4 networks, they rely heavily on broadcast traffic so that devices can be plugged into a network and dynamically learn their own addressing of how to communicate, as well as the addresses of other services and devices on the network. So some of the protocols that really heavily utilize broadcast are DHCP is one, and ARP is another one. Without those dynamic communication and just bringing a device into the network and having it start working, that'd be near impossible. So there's one more communication type we want to talk about, and that is Anycast. This is very specialized. This isn't something that you're going to see super common like these other types of traffic are, because in this situation, these different receivers are actually all assigned the same unicast IP address. And so the sender, it's just sending traffic out, and it doesn't really care which of the receivers gets that information, just as long as one of them gets it. So I've seen this used in networks where a certain service that you might have, we'll say like a DNS server that's in different places throughout the network. You just want all of your endpoints to send traffic to a single IP address and to just get to DNS. And so you just assign all those DNS servers the same address. Endpoints can send DNS queries to that single address, and that's considered Anycast because each one of those receivers, they will answer for that unicast traffic. So the 4 communication types: unicast, multicast, broadcast, and Anycast.